today we are looking at the second application. We did annuity. Now we're on the amortization. Now this is simply a process of structuring out your loan payment. Because we are in the developmental field, there are times you may take loan for certain projects to be done, and you want to know how this loan deductions will be made across whatever conditions that was given. And that is the whole idea of the amortization. It deals with the time value of money, because as time progresses, your loan payments or whatever you give to your lender increases. Alright, so let's take this example here. It says consider an institution that borrows 1,000 Ghana cedis, and then the loan has to be paid in 3 equal installments at the end of the next 3 years at 6%. Take note of the highlight information. Okay, you realize that here the loan is taken once and there's no regular payment. You realize, so it means our PMT will be 0. All right, it says structure the loan schedule. Structure your loan schedule. In Excel, there are certain key syntax to help us get this loan schedule done, and that's these bullet things. So we've seen rate already, and we want to look at interest payment, principal payment, and then loan payment. As described in the lesson, loan payment is what is deductible at the end of the year. It includes your principal and then your interest. So loan payment is the addition of the principal and the interest rate. Okay, but you realize that the balance rate or the balance payment after your deductions will not include the interest rate, because it is not for you. It is what the lender aims from you. So we are going to use these syntaxes to see how we can schedule loan payment with a preamble given. Let me take this off, and so let's start. With all the information given is what I have done here. So I have my let me get this done. I have my interest rate given at 6%. The number of periods is 3. The loan taken here is 1,000 Ghana cedis. Again, don't forget it is being given out, so it's -1,000. The future value is 0. We don't have any future value. We just want to schedule from how much we can pay from 1,000 to for the next 3 years. And so these are the syntax we are going to use. The loan payment is PMT, IPMT for interest, and then PPMT for principal. We'll get to see the inbuilt syntaxes soon, or argument. So this is how your table would always look like. You have the year, you have the beginning balance. What are you starting with? You have the loan payment. Since we are paying yearly, this loan payment is the addition of these two guys here. So we have interest rate payment and then the principal payment, what's actually deducted from the loan you took. And then we can have an ending balance. So at year 0, that is when we took the loan. Our ending balance is 1,000 Ghana cedis. All these columns here are 0. So let's see what we can have for our loan payment after year 1. What are we being deducted from? So equal to PMT. It says it is returning the periodic payment of annuity based on something. Alright, so regular payment. So PMT into bracket, I enter. It says find the rate first. Where is my rate? Here you are. The number of period is 3. No, so in this case, my number of period is the 1 year. Yeah, is the year 1. Okay. Then the PV is given as my principal money, and then the type. Most of the time, okay, I'm not at the type yet. The PV is 0, and then the type. Denote the beginning and end. Most of the deductions are done at the end of the month, so I'll choose 0 here, and let's see. I'm not sure this is correct, so let me do it very well. Let me start all over. It is even more than our loan. So equal to PMT. The rate is 6. The number of period is 3. Yeah, thanks. And then the present value is that. The future value is 0. Then the type, let's use 0, deduction at the end of the month. All right, so this is correct. It means in year one we are being deducted of $374. But what is the component of our loan payment given these two guys? We can check them. So what was the interest rate paid? IPMT. It says find what is the rate. So this guy, comma, the period. So that's where we check in period one. There's even between period and end period. Period is what you are currently in, comma. Then the number of periods is actually now 3. The present value is that. The future value is 0. And the type is 0 here. So it means that out of the loan payment of $374, you're actually paying an interest rate of $60,000 or $60. And so principal can simply be my loan payment minus my balance to give me my principal. Okay, that is the alternative. But if you want to use the syntax given, that is equal to PPMT. Alright, so it says the rate. Let's see if you're going to get the same amount. The rate is that. The period amount period 1. The number of period now is 3. The end pair. Present value that. Future value that. Type is 0. And you see we have the same value as we expected. So these two guys match up to the loan payment. And what will be our ending balance? It will be whatever you started with minus the principal. Again, your ending balance is not being influenced by the interest rate payment. That is the earnings to the bank upon the loan you took. So we deduct just our principal. That's it. So it means in year 2, in year 1 our beginning balance was 1,000. It means that in year 2 here our beginning balance will be this 1,000 here minus whatever has been taken. Sorry, not that. Yeah, so I can just simply say this now, this guy. Let me not complicate myself. At year 2, this is what I'm starting. My beginning now becomes, no, let me take it again. My ending now becomes my beginning. Exactly. My ending now becomes my beginning. So realize that in year 1, our beginning becomes whatever we started off with. So our ending becomes our beginning. Right. So let's see, I can easily drag this one to give me the last, which is 0. I've not found it, so it's 0. So what's the loan payment? I can drag this thing down, but it might not work. So I want to just be sure of the things that are not changing. So realize that the rate is not changing. The number of the end pair is also not changing. Okay, what again? The PV is not changing. The FV is also not changing. Our type is not changing. So this actually makes sense. Our loan payment for every year would be the same. It's a constant, so I have a tail for you. It's constant. The loan payment is constant throughout. But then your principal may change, your interest rate may change. So can I easily drag this one down? We attempted to always drag. You see the error. So what can we maintain? My rate is always maintained. The number of the period is varying, so I leave that one out. But the end pair is fixed. The PV is also fixed. The FV is also fixed. Yeah. Now I can drag this one down, and then it should work. So look at it. As years progresses, the interest payment reduces, and then your principal increases. So I can't simply drag this one as I said. No. So there are things that need to be absolute. Our rate is not changing. Our number of our period is changing, but our end pair is fixed. Our PV is fixed. Our FV is also fixed, and that is it. So I can now drag this one, and then that is my deductions. As the year progresses, the principal increases, and then the interest rate reduces. If you want to confirm, I said that these two guys must add up to your loan payment. Okay, so now we can check what was the balance and ending balance if I drag this. So at 3 years we would have finished paying off the loan as expected, and that is how simple this is. So you started with 1,000, that at the end of the 3 years you would have been finished paying your loan. So alternatively, if you don't want to use the the syntax is given. I've already explained this, guys. Here it's simply equal to, look at the syntax, this minus that, so I can easily drag this one. But you see what is happening is because here and here are 0, so if before you drag, I'm using the syntax here, I made 6% of this, the next one can be 6% of whatever we had before previously, but I don't want to go through that approach. I may not be able to get it, so this will be equal to IPMT. Wrong, let me check the syntax for rate. The rate is, yeah, IPMT, so I was right. IPMT. The rate, I have to now go up and pick things. The rate is 6. The period, now I'm on the first period. The end per is 3. Then the PV, I hate scrolling up and down, and then my FV is that, and then we are using at the end of the month, so 0. Before I drag, I must fix certain things. The end pair is fixed, the PV is fixed, the FV is also fixed, so I can undrag this, and then I'll have whatever I was expecting as before from up here. They are the same thing, so either you use a syntax or you can use a difference, and that is what I want to show you in this episode. So I have a question here for you. It says draw the loan schedule for amount of 10,000 for 5 years at 10%. You want to try this one out, and as simple as that. See you in the next episode of the third application of our time value for money. Thank you.